Hi guys, just a quick intro to this one. So this was just a repair video, usual sort of repair, things that come into the workshop, but during the repair I thought of something I thought was quite interesting, and this will teach you quite a bit. So this is another video about short circuit finding in VRMs. It doesn't matter what I'm actually doing it on, it's the way I do it that matters. So you can do this same thing, use the same principle on graphics cards, motherboards, all sorts of things. Okay, so watch, enjoy, and hopefully you'll learn something. Hi guys, welcome to Learning Electronics Repair. I have another one of these mag boxes here. I've fixed a few of these on the channel before. So we have quite a lot of these around on the island, and to be quite honest, they're quite hard to get because the company who make these, if you look on the label, are based in Odessa, Ukraine. I mean, I think these are actually made in China most likely, and they're imported via Estonia, and for quite a while now we've struggled to get them, which basically means that used ones tend to sell on eBay and such places for not much less than the new ones, just because there's a shortage. So this one apparently is faulty and definitely worth repairing if I can. Apparently it is dead. Now, I've previously tried the power supply with this and plugged it in. It is dead, and I tried the power supply and the power supply is dead. Okay, so that much we do know. So what I'm going to do is I'm going to just connect this to my bench power supply first and see if the problem was just the power supply. But if it is, well, it's not much of a video. This particular model is 12 volts, 1 amp. You can see positive to the center conductor, which is standard. These draw about 0.65 of an amp when they're running, something like that. I've seen them before, I know what power they draw. So we'll try and power this up from one of my bench power supplies. We'll use this one, so it's on 12 volts. I know they draw about, as I say, 0.65 of an amp, so I'll just set a current limit on this then. So it's on current limit 150 milliamps. I'll turn this up to about an amp or so, something like that. Okay, then if there's something wrong like a short, it's not going to blow anything up. The reason for that is the original power supply can supply 1 amp, but this can supply 5 amps. So if you feed it into a short, you may just make things worse. I just need to check I've got a spare power lead here. In fact, I think I cut this one off the faulty power supply. Just need to make sure which of the wires is the center one. Okay, continuity range, outside connector, well, we can easily get on that one. So it ain't that one, it's that one, is it? Oh, is this lead good? Let me just have a look. Well, the meter's working. Yeah, so that one with the white stripe on it, that is the negative. There's no short in the lead, although that'd be unusual for one of these unless it's damaged here. And that's the center conductor. Okay, so this is the negative. Right, let's see what it does. White stripes, okay, power it up. Okay, and that is gone into current limit. You can see it's drawing more than an amp, so there is a short on this in actual fact. So let's see if we can find it. Has the warranty seal on this one's never been opened before. Always use your bench power supply like that, guys, if you've got something where you think you might have a short, because as I say, in this case the original power supply can only supply 1 amp. This can supply 5 times more. It happily will, and you may easily end up just making things worse. So let's see. I'll switch that off because it's making a noise. You can probably hear it. It's probably annoying you. So if you've watched the channel, you might have seen inside one of these before. A couple of screws holding the PCB in. And there it is. So let's see. We have the 12 volts coming in here, and the first thing you see is a chip, that one. And this is basically a buck converter or controller, drives a coil. In fact, there's a few coils on here. You can see another chip down here. And you can see some voltages marked on the board there. 1.5 for the RAM, 0.95 for the CPU, that's this one, okay. 3.3 is this one, 1.5 is this one. This one is, yeah, 5 volts, so that's a 5 volts that actually comes here. And those are the power rails. So this thing doesn't actually run on 12 volts, it runs on a load of derived voltages. The 12 volts only comes to the input. And from experience, usually one of these chips goes short circuit, and that's usually where the problem is. But on occasion, it could be one of the capacitors. Let's just zoom down a little bit. Okay, that's actually maximum zoom. I'm just wondering if this chip looks a little bit distressed, maybe. Let's get it under the microscope and have a look. Well, in fact, when we have it under the microscope, we can see it doesn't look distressed. Neither does this one. There's something across there. Let's have a look. Just here. What is that? Well, I don't think it's conductive, whatever it is, but it shouldn't have been there. Okay, so let's see if we can actually find the short. Okay, so this is your power coming in. Negative, positive. I actually don't read the short there. That's interesting. That's very interesting. If I don't read a short there. Let me have a look. So this is the inductor, which I'm pretty sure, if we look at where the tracker's going, I'm pretty sure that goes to here. Looks like it goes that way. Yeah, it looks like we have a pin up here, probably this one going to one end of the coil, and then the other end of the coil goes off that way onto the 5 volt rail. Yeah, this one, 5 volts. So from the end of the coil goes to here. No. Goes to that one. Okay. And then the input to this will come from the 12 volts. Somewhere. Oh dear, hold on. No, there isn't a connection there. I thought for a moment I had a short direct to the coil, because that would put 12 volts straight into the circuit, like a high side MOSFET inside here short. I don't have. Not that pin, not that pin, not that pin, this pin. So this pin is the 12 volts in. One of the other ones will be ground. Probably that one. Yeah, so it's 12 volts in, ground, and then this is the drive to the coil. Yeah. So actually, I don't see a short now. That's ground. This reading 266 ohms. Why is this drawing like 1 amp? Yeah. I thought maybe that there was a short from here through this into like the low voltage part of the circuit. Let's just move it off the microscope a minute. Yeah, as I was saying, I thought there was a short from the output of this to the coil, yeah, which generates the 5 volts. I don't think any of these other chips go to the 12 volts. Yeah. Do we have a short from the 5 volts to ground? That might explain why. So the thing's working okay, but we have a short on 5 volts. In fact, do we have a short on any of the coils to ground? Let's have a look. Because if there's no short on the input and it's drawing a lot of current, then the short could be on a derived voltage rail, which is just all the other voltage rails on here. So the way to test this is to connect from ground to all of these inductor coils and see if we have a short. Yeah, 0.3. And that is on the V core. That's this. Just go to resistance range, because this will probably have quite a low resistance anyway. What do we have? Yeah, that looks like a short to me. I think I have another one of these we can just compare with. So from here, no short, that's the 5 volts, okay. From here, this is the 3.3. No short. From here, this is the RAM. No short, but on this one, which is core, is short. That then means it's that, and there's nothing we can do about it, to be quite honest. Apart from use this one as spare parts using these regulator things if another one is faulty, yeah? Let me see if I can just find another one of these and we'll just measure that resistance on the other one to compare. But from memory, it reads some ohms. Okay guys, so I actually have another one of these here now. This has never been opened either. You can see 2018. This is not exactly in warranty, so I'm not too worried about that. It is the same model. So let's just have a look at this one and we'll compare the resistance on the core. But I'm sure from previous experience with these, it's about 10 ohms or something. Should be. Okay, so let's have a look. Take both screws out first, that would help. Right. Okay, so this is a good one. Let's see what we have. Ohms range. So from here to ground. Yeah, 11 ohms. That's close to what I thought it was. And on ours, 0 basically. Yeah. So we have a short on here. The only possible thing that it could be that we may be able to fix, I guess, is probably if we have a short circuit capacitor down here somewhere, maybe. So what I'm going to do is I'm going to put a bit of voltage in on this coil. It says this is 0.95 of a volt, so we'll stick something like 0.9 of a volt in here. Yeah, and let's see what gets hot, if anything. Of course, you guys will know I often decide to do one thing, then think I'll just do something else first. So another possibility, because there's always possibilities, as well as having a short circuit capacitor or this chip being faulty, the big BGA. The fault could be on the supply side of this, on the controller. Yeah, it could be on this side. So the way to find that out is to see if we can measure the resistance to ground either side of this coil. Whichever side reads the lowest is where the problem is. So if we go to ground and we measure to here, we have 136 milliohms. Okay, so this is a micro ohm meter in actual fact. We go to the other side of the chip, so we keep ground on the same place. Yeah, I don't measure ground somewhere else because it may just be a shorter circuit track to the ground. on here. And that's 148, 150. So it looks like on this one, the lower resistance is this side. Let's see. Well, we don't need to trace it through, because if we look at the PCB track, that comes directly to this chip. And this chip also, you can see, controls this one and this one, okay? So it's looking like the short circuit is on this side, not on that side. To be certain, we could just unsolder the coil. That would give us a very good indication. But if we try to inject some current, as I mentioned, we'll put a voltage about 0.9 of a volt. We'll solder a wire on here, and let's see what gets hot. If this is getting hot, this is where the problem is, or something on this side. Yeah, capacitor maybe. Let's see if we can tell with the thermal camera which side the problem is. I've soldered a wire on so I can inject some current into here. I was just thinking about this, as I do, and it occurred to me, I've never really thought about this before, but if I inject current at this end of the coil, and the short is on this side of the coil, then all the current is going to flow into the short. Yeah. So if I take a millivolt meter and measure across the coil, I should see basically zero, because there's no current flowing through the coil. And you know where this is going, don't you? Because if I attach the wire here and the short is on this side of the coil, where it appears to be, and I measure the voltage drop across the coil, if the current's all flowing this way, I'll read the voltage. What do you think? What do you think? Theory sound, yeah? I've never seen anybody do this. Maybe they have, I just haven't seen them, but I haven't seen it, so let's have a go. Here's the power supply. I've set it to 0.9 volts, which is below the rated voltage for this rail. Now, if there is a short, it would pull the voltage down low anyway, even if I set it higher than that. But if whatever short goes open circuit due to the current I'm sending into it, it may go open circuit, and the voltage will go up to whatever this can supply. Now, I've set this to 5 volts, then all of a sudden there'll be 5 volts coming into here, and if this wasn't dead already, it will be now. So that's not what we want to do. What we want to do is clip our ground on here. Get a good ground, okay. I'll just switch the power supply off a moment. I'm going to connect my 0.9 of a volt onto that red wire, and I'm going to measure across the coil. Let's just get a camera where you can see the meter as well. Okay, you can see everything there. I'm on millivolts. Okay, millivolts. So if I connect the red lead to this one and the black lead to here across the coil, I should see a positive voltage drop across this coil if the current is flowing through it. So let's see what this actually does. Power on. I have about 5 amps going in, you can see that. Let's measure across here. And we have 60. We have 60 millivolts flowing through that coil. So we have a lot of current flowing through the coil. I'll just see if anything's getting warm, but it may not do. But this does tell us that the fault is on this side of the coil. I can take my thermal camera anyway and see if that also tells us the same. And then if we measure the resistance of this coil, we can see whether all of the 5 amps is flowing through it, actually. I have the thermal camera switched on. I've taken the macro lens off just for a moment because I want to see the whole board and I want to see if something gets hot when I put the current on, okay? And it looks like something here is getting rather hot. Oh, 70 degrees, and it's the chip. Switch that off a moment, put the macro lens on. You can see it's still hot down here. Okay, you can see that chip quite clearly if I move the lead out the way. Okay, that's the controller for the VRMs. Switch it on again. Yeah, look at that. 70 degrees right in the middle of it. Okay, 75 degrees. So that is where our short is, and that technique worked really well. As a last thing, let's see if we can actually figure out what current was flowing that way. Okay, so let's see what the resistance of this coil actually is. Well, it's about 16 milliohms. Okay, say 16 milliohms. So, what current was flowing through the coil? Well, we can use Ohm's law, and because we're measuring in millivolts and we're measuring in milliohms, we don't need to worry about the decimal place either. So, current is voltage over resistance, V over R. Okay. So the voltage we measured across the coil was about 60 millivolts. And we can divide that by the resistance, which is about 16 milliohms, yeah, roughly speaking. So if we can work that out, that's 3.75 amps. Now our bench supply shows about 4.3 amps, so a little bit of current is going somewhere else, fair enough, or there's a little bit of inaccuracy in the measurements. But we can see that 3.75 amps was going that way. And that chip was getting hot. So without using the thermal camera, just at least feeling around, which you could do anyway, but just by using a bench power supply and a multimeter on millivolts range, this is equipment you've all got, I would say, you can figure out which side of a coil the short is. Yeah. Just inject current on one side and measure the voltage across it. If you see a voltage, that's the way it's going. Yeah, you can always inject on the other side and measure the other way. You'll soon find out which direction it is flowing. Yeah, that's nice. This will also work on multi-phase VRMs as well. So if you have, say, a 6 or 8 phase or 3 or 4 phase VRM on a graphics card or on a motherboard on the V core for the processor, and you inject voltage onto the core, the low voltage side, you can then measure the voltage across all of the inductor coils, because one end of all the coils are connected in parallel to V core, another end go to different pairs of MOSFETs, and whichever coil you see a voltage drop across is where the short is on the MOSFETs on the other side. Yeah. If you see a voltage drop across more than one, then you can do a little bit of maths like I did. If you see the same current flowing through more than one, say you've got half the current through one and half through another, you know you've got shorts on 2 of them. Yeah, it's as good as that, guys. So this chip, well, it's getting hot, so it looks like a faulty chip. I did check this before. We don't need to worry about capacitors and things on this side now. We know that's not what's getting hot. We know it is this when we inject the current there. We know the fault isn't on this side because the current's all flowing that way. The only other thing that could probably cause this chip to fail or get hot would be if there's a short on either of these other 2 rails. So you can see clearly this chip drives 1, 2, 3 coils, 3 voltage rails. So let's have a look. I did check them before, so I know they're okay. But just to remind ourselves, okay, ground, yeah, there's no short on that one, there's no short on that one, and the fact we read a short on this one doesn't matter because we know which side of the coil the short is. I haven't got any of these chips, but let's have a look to see if we can get some. Well, probably have to put it under the microscope, but no, I can read these IPS 65265 and think actually it is TPS 65265. Let's have a look. I can get one for €2.43, but to be quite honest, I think I'll order a pack of 10 of these. I see quite a lot of these boxes, so it's definitely worth me getting them. If I fix one of them, well, I get about €65 for one of these boxes used anyway, so it's worth it to me. Okay, so can't just fix it today, guys, but I think we did a good job there of finding where the fault was. Yeah, I've not done that before. Hope you guys like it. Yeah, I don't know why I never thought of that actually, because it's such a obvious one, but often the obvious ones I don't think of, maybe at 4 AM in the morning, but this time it came like a lunchtime thought. Okay, hope you enjoyed that, and I look forward to seeing you all soon on another Word Electronics Repair video. Ciao for now, guys.